It is rare when a problem shows up in your textbook or anywhere that enfolds so many things. But when it happens, it's one of those, gotta do it, gotta show it to you, gotta work it out. This is problem number 77 on page, I think 368, maybe 358. Here's the problem. We have 2 to the 2 divided by the log base 5 of x is equal to 1/16. And we want to solve for x. This is an example of a logarithmic function or a logarithmic equation, and we want to, it's an equation because it has an equal sign. It's a logarithmic because it has a log. And I want to show you how we use inverse functions to get this figured out. What I'm going to do first is I'm going to write 1/6. I noticed that I have 2 here. So I'm going to try to write everything in powers of 2 right off the bat. And 1/16 is equal to 2 to the minus 4 power. Remember, 2 to the 4th is 2 times 2 times 2 times 2. That's equal to 16. But if I put a minus sign in front of there, that throws it into the denominator. So 2 to the minus 4 is 1/16. Just a quick review of exponents and things like that. Okay, now I've got 2 to this power is equal to 2 to the minus 4. Now I could just say, and I could save a lot of time actually this way by saying, well, this exponent is equal to this exponent, and I'm actually going to get there, but I'm going to go instead by taking the log base 2 of both sides. Right now I have an exponential function happening. To get the exponent all by itself, I'm going to take the inverse function, which is the log base 2, and I'm going to write that here, log base 2, and I'm going to write that here, log base 2. And remember from our logarithm, log base b of b to the x, this is a fundamental toolbox thing you're going to always want. Log base, if the base is the same, this is equal to x. I basically am taking right now the logarithm of the exponent, and I get what I usually get when I take an inverse function times the function, I get x. If I say usually, always. I always get that. So log base 2 of 2 to this power is equal to log base 2 of 2 to this power, which means this is equal to this. So 2 to the log base 5 of x is equal to minus 4. I want to get this log all by itself, so I'm going to do that by multiplying this equation through by the log base 5 of x. Wipes out that denominator here, and I get 2. Let me draw an arrow. I get 2 is equal to negative 4 times the log base 5 of x. Almost there. Now I'm going to divide both sides by negative 4, negative 4, negative 4, and this reduces, of course, to minus 1/2. So minus 1/2 is equal to the log base 5 of x. I'm almost there. Let me keep my original problem here. 1/16. Okay? To get this, to get rid of the log now, I'm going to make this an exponent, and because my log here is to the base 5, 5 is the number that's going to be here. So 5 to the minus 1/2 power is equal to 5 to the log base 5 of x. And because of the rule that b to the log base b of x is equal to x, again, it's my inverse function rule. I'm going to end up with that. Toolbox. Write this down. Put this in your toolbox. Memorize it. This is good stuff. Then I get 5 to the minus 1/2 power is equal to 5 to the log base 5 of x is equal to x. This is my answer. But 5 to the minus 1/2 power, so many people get stuck on this. They think, what is 5 to the minus 1/2 power? And first of all, what's 5 to the 1/2 power? Because the minus sign says put it in the denominator. Well, 5 to the 1/2 power is the square root of 5. I can prove that by saying 5 to the 1/2 times 5 to the 1/2 is equal to 5. Add the exponents, 1/2 plus 1/2 is 1. And isn't it true that the square root of 5 times the square root of 5 is equal to 5? 5 to the first power is 5. There we go. To the minus 1/2 power means that x is equal to 1 over the square root of 5. Be very careful not to ever think that you can put a minus sign on this because of this negative exponent. The negative exponent only says put it in the denominator. It does not say make it negative. It's not. It can't be. If you remember your exponent curve, it is always above the x-axis. It never goes below. It is never negative. This is our answer, but like all good mathematicians, let's be really confident of our answer by checking it. I want to put 1 over the square root of 5 in here for my x value and see if this is indeed true. Well, the log base 5 of 1 over, let's write it here, 2 to the 2 over log base 5 of 1 over the square root of 5 is equal to 5 to the minus 1/2 power, which we talked about, which is equal to 2 to the 2 over minus 1/2. Log base 5 of 5 to the minus 1/2 is minus 1/2, which if you do the fraction is equal to 2 to the minus 4 power, which is indeed 1/16. It works. 1 over the square root of 5 is our answer. This was a beautiful problem because we got to pull so much of our toolbox into finding out this answer.